So we are still in this 1 to 10 ton carbon footprint items. So we are now looking at 1 ton of fertilizer, which has 2.7 tons of CO2 equivalent if it's nitrogen fertilizer efficiently made and sparingly spread. Those are kind of objective statements, but nonetheless it can jump to 12.3 tons of CO2 equivalent if the same stuff is made inefficiently and used in excess. So we'll look at some figures, some numbers where the nitrogen fertilizer is being used excessively and so on. A real carbon opportunity up to 0.5% reduction in global emissions. It's dead easy and has no bad side effects. So this probably needs a context. The Haber-Bosch process, which industrialized ammonium production, was hailed as something that saved lives, millions, maybe hundreds of millions of lives. People also say that's what led to bombs, but let's not get into that argument. Then the second one is, of course, that there was the Paul Ehrlich statement about the population bomb, a book from the 1960s, I think, which claimed that we're going to have a Malthusian crisis because the population was growing super exponentially. Then came the Green Revolution, which obviously increased the food supply yield per acre to levels where such a large population could be supported. And as we said before in the other podcast, right now production is enough, but the wastage can make starvation much worse. So it's access, quantity and quality of food rather than just the net production. In that context, fertilizer, Green Revolution, we will see that not everybody agrees Green Revolution was a good thing. It had pros and it had cons. So let's go through the nitrogen, potash and phosphate fertilizers across the world. So nitrogen fertilizer use per hectare of cropland in 2017. Application of nitrogen fertilizer measured in kilograms of total nutrient per hectare of cropland. So the scale here is going from 0 to 500 kilogram, and you can see that fertilizer per hectare is very high in this region of India, Pakistan, China, and these are what Korea's coming down here, and of course Southeast Asian countries, and there is plenty of use in other countries as well. So the developing world may be using excessively, especially here in Egypt, for example, and of course Europe is doing its own bit as well. This is just for 2017. To look at a longer context, world population with and without synthetic nitrogen fertilizers, estimates of global population reliant on synthetic nitrogen fertilizers produced via the Haber-Bosch process for food production. Best estimates project that just over half of the global population could be sustained without reactive nitrogen fertilizer derived from the Haber-Bosch process. So when you grow crops, they are taking up nitrogen from the soil and you are shifting it into food items, so you have to put the nitrogen back into the soil. When you apply it is very critical. If you put it when the seed is still not is not a seedling and ready to grow and take up nitrogen, you could be wasting it and washing it away and so on. But leaving those details aside, if you go from 1900 to 2015 or so, the world population has definitely grown a lot. World population supported without synthetic fertilizer would be here, and world population fed by synthetic fertilizer has been here. So you can add these and we ended up with this total number that we have now. Okay, just to give you a sense. World population supported by synthetic nitrogen fertilizers, so population fed by synthetic nitrogen fertilizer and population supported without synthetic nitrogen fertilizers. So there are countries where obviously still food production happens without synthetic nitrogen fertilizers. That's what this map is saying. So you can see that there are lots of countries where either there is no data or very little of the synthetic fertilizer is being used. Fertilizer use per hectare of cropland in 2018. Again, this includes nitrogenous, potash and phosphate fertilizers, including ground rock phosphate. Animal and plant manures are not included in here. Application rates measured in kilograms per hectare. So China dominates, Egypt, Brazil, and of course India, Australia, and other countries are up there as well, and Europe and North America. So total fertilizer production has obviously gone up from 1961 to 2014 in millions of tons, which most of it is nitrogen fertilizer. There is also phosphate and potash or potassium fertilizer. Nitrogen fertilizer itself, this itself can be split into where it is being produced. So North America has dropped off and leveled off. Central America is steady. Europe has dropped off and leveled off. Asia has increased and probably is continuing to increase, and Oceania, Caribbean and Africa add a little bit. So India and China obviously dominate nitrogen fertilizer production. They are subsidized in all sorts of ways for farmers, and of course there are associated issues in terms of water quality, soil health, generally pollution, N2O emission, and so on and so forth. But food production is high, so a country like India has become self-sufficient in its food production and even exports a lot of things. Phosphate fertilizer consumption from 1961 to 2014, again Asia dominates, so it's not just nitrogen fertilizer, but also the numbers are different. Here we are in tens of millions, here we are about half of that. Nitrogen fertilizer consumption, so production versus consumption, obviously most of it is consumed in Asia. Potash fertilizer consumption, same story, Asia dominates. So these other countries have dropped off, so they peaked earlier and they have dropped off. So whatever pollution we have now, just like carbon, we have to always look at historical numbers as well. And we will do that in the next podcast, where we look at per capita emissions and try to match up these population growth, cumulative emissions, and per capita emissions. These numbers can make you pause and think about how to place responsibilities, right? Equal but differentiated is often the phraseology used by the UN Intergovernmental Panel on Climate Change and so on in terms of climate action. Excess nitrogen per hectare of cropland. Amount of excess nitrogen per hectare is the difference between nitrogen inputs and amount harvested in crops. So you're getting certain amount of nitrogen back in harvested crops, and you have put certain amounts. The difference can be used to estimate excess. So here China dominates, Pakistan, Egypt, Middle East, surprisingly, because they are doing a lot of desalination and dumping lots of nitrogen fertilizer to grow crops in the desert. Yes. And here is, I think this should be Venezuela, maybe. You can check it out. Okay, so here again are the numbers. So obviously water and fertilizer are used excessively by farmers in general because they want to be safe, and there are lots of evidences that even when there is good rain, irrigation water use is unnecessarily high, a lot of evaporative losses, but also soil logging, water logging, and other problems happen. From this paper here, which is a short review on the Green Revolution, I wanted to show this as well. What has happened with Green Revolution? Going from 1961 to 2018, obviously production of wheat has gone up. Soybeans, rice, paddy, beans, maize, seed cotton, pigeon peas, chicken peas, sugarcane, and so on. But there have also been drop-offs in jutes, peas, dry. So here we have different one. Oil seeds, safflower seeds, sesame, pulses, linseed, groundnut with shell, barley, millet and sorghum have dropped off quite a bit compared to 1961, the numbers in 2018, and there are lots of health benefits and they are environmentally friendly compared to some of these other crops. So there is a lot of effort to bring millets back in India, for example, and there is increasing demand and there is increasing supply to meet that increasing demand. So millet revolution will probably be good for reducing deforestation and soil degradation and improve soil health, maybe even soil carbon sequestration and so on. This report here, Our Endangered World lists, it's a good report. I just took the table of contents. So Green Revolution pros include increased food production, consistent high yields in unfavorable conditions, low food prices, environmental sustainability, improved immunity in plants, reduced need for fallowing, accurate harvest predictions, and greenhouse technique, the greenhouse hothouse kind of technique. The cons of Green Revolution have been Green Revolution crops are dependent on fertilizer, which is what we are talking about. Adverse effects on the environment, so there is environmental sustainability and adverse effects, so you have to see what are the factors. Increased food waste, this is something that must be addressed. Seed sterility, which has been a side effect. Global expenditure has gone up. Exponential rise in production of cash crops like sugarcane that we saw, cotton, sugarcane, and so on. The Green Revolution is not the solution we were looking for. That's kind of the big message, that maybe there is a need to go back to more organic, environmental friendly methodologies and crop selection, especially in places like India where extreme events and warming are combining to make some crops untenable now. The future requires a more careful crop selection as a part of climate adaptation, agricultural adaptation to climate change. So obviously Green Revolution did get us through some tough times, but also allowed population growth. But now population growth is retarded seriously because of educating girls and women. Fertility rates have been dropping. Population is expected to also potentially drop in the next coming decades because of educating women. But the story is a bit more complicated in the sense fewer kids doesn't mean reduced consumption. So consumption is still going up. So all these various factors have to be considered in the bigger picture. But fertilizers, good and bad.